We'll now continue with section 7.3, this time looking at product to sum identities and sum to product identities. We're going to begin with the product to sum identities. You can see that we have 4 identities listed on the screen. We're going to look at an example to see how to apply these identities. Our example asks us to express sine x raised to the 5th power in terms containing only first powers of sine. If you recall, we have looked at this problem previously. We worked it in the first lecture presentation for section 7.3. The answer that we came up with at that point is given here on the slide. So what we want to do now is look at our answer and see whether we can further simplify this answer using these product to sum identities. So the first thing that I want to do is look specifically at this part of the problem. And we want to apply one of our identities to this. So I'm going to use the one that starts out with cosine and then sine. And so what I want to realize is that when I compare what I have in my problem to my formula, I need to realize that the x in the formula is now going to be played by 2x. And the y in the formula is going to be played by an x. So everywhere there is an x in my expression, I'm going to go ahead and put the 2x. And everywhere there's a y in my expression, I'm going to go ahead and put the x. So we can see now that this expression can be simplified to some extent. So we'll have sine, and 2x plus x will be 3x minus sine. 2x minus x will be x. And so what I'm going to do is I'm going to take this expression here and I'm going to plug it in right here. I also want to look at this part of the problem. And I want to go back to this same identity that we just looked at. And let's apply cosine 4x sine x. So again, on the cosine, instead of having an x, we're now going to have a 4x. So everywhere there's an x in the expression, we'll be putting in 4x. And for the sine x, that will be the sine y. So everywhere there's a y, we're going to be putting an x. So my expression now becomes 1/2 sine, we have 4x plus x, that's going to give me 5x, minus sine, and we have 4x minus x, so that's going to give me 3x. And I'm going to take this expression and plug it in here. Okay, so let's go ahead and make those 2 substitutions and rewrite our problem. So I have 1/4. I have 3 sine x over 2 minus 2, and now I'm going to make this substitution. Plus, we're going to substitute on top of this fraction. and put that over 2. Okay, so once that's done, let's look at simplifying. So I'm going to clean this up just a little bit so we have some room to work. Okay, so the first thing I'm going to do is I'm going to multiply this 2 times this 1/2. So we know that when we do that multiplication, 2 times 1/2 is going to go to 1. So that's going to simplify that. I'm also going to go ahead and deal with this 1/2 divided by 2. So 1/2 divided by 2, remember that we're going to treat that like 2 over 1. And so it's going to be 1/2, not divided by 2 over 1, but multiplied by the reciprocal. So that part's going to become a 1/4. Okay, so let me rewrite again and sort of clean up as I go. So I'm going to leave that 1/4 there. I'm going to have 3 sine x over 2 minus the 2 and the 1/2, remember, cancel out. So it's going to become minus sine 3x. And we want to be careful here. We've got a minus applied to a negative, which is going to make a positive there, sine x. Plus, we've already talked about the 1/2 and the 2 making a 1/4. Right, and I'm going to go ahead and distribute that 1/4 through that parenthesis. So it's going to be 1/4 sine 5x minus 1/4 sine 3x. So the next thing I'm going to do is take this 1/4 on the outside of the parenthesis, and I'm going to distribute to each term inside the parenthesis. So 1/4 times 3/2 is going to be 3 over 8. And then we have a sine x. Minus, we'll have 1/4 sine 3x plus 1/4 sine x. 1/4 times 1/4 is going to be 1 over 16 sine 5x. And then we'll have another 1 over 16 sine 3x. Now, the only thing left is to combine like terms. And so let's look at that. We do have 2 terms that have a sine x. So these 2 can be combined. So 3 over 8 plus 1/4 is going to end up being 5 over 8. Sine x. And that's going to take care of that term and that term. All right, let's look at what else we can combine. We have a negative 1/4 sine 3x and a negative 1 over 16 sine 3x. So adding negative 1/4 and negative 1 over 16 gives me 5 over 16. That's going to be a negative 5 over 16. And that's going to be a sine 3x. And that's going to take care of this term and this term. And then the only thing that's left is going to be the 1/16 sine 5x. Okay, and that completes that problem. All right, let's move on and let's look at one additional example. We need to bring in the idea of the sum to product identities, which you can now see on your screen. All right, and again, we're going to look at an example to try to see how we use these identities. So our example says that we want to verify the identity sine 2x plus sine 4x over cosine 2x plus cosine 4x is equal to tangent 3x. So we're going to start with the left side of this identity. So I'm going to write that down, sine 2x plus sine 4x divided by cosine 2x plus cosine 4x. And we're going to use one of these identities for the top part of the fraction and also for the bottom part of the fraction. So for the top part, notice you have a sine plus a sine. So we're going to be looking at this first one. Now again, we have an adjustment to make because our problem is sine 2x. So this x is going to become a 2x. So everywhere there's an x, we'll be putting a 2x in the formula. And instead of a sine y, we have a sine 4x. So everywhere there's a y, we're going to be putting a 4x. Which means we can do a little bit of simplifying there on the top. So I can write that the top is equal to, and I'm just going to be writing this part of the expression and simplifying as we go, 2 sine, all right, 2x plus 4x is going to be 6x over 2. And 6 over 2 is equal to 3. So I'm going to go ahead and change that and make that just 3x. And then we have cosine, and we have 2x minus 4x. So that's going to be minus 2x over 2. And again, that's going to simplify to be negative x. And so I'm going to go ahead and make that change as well. All right, let's look at what's happening on the bottom. So on the bottom, we have a cosine and a cosine. So we're going to be using this identity, cosine, cosine, with a plus in between. Again, we're going to have to adjust a little bit. So cosine 2x is where we start. So the x's will become a 2x. And the second term is cosine 4x. So the y's will be a 4x. Okay, and so I'm again going to just sort of write this in simplified form as my new denominator. So we'll have 2 times cosine. We have a 2x and a 4x, again making a 6x over 2, which is going to give me 3x. And the other part's going to be cosine. Here we have a 2x minus 4x. That's going to be a negative 2x over 2. So again, another negative x. Okay, so as we're looking at this, we now see that we have a term that's going to cancel because we have the same term in the top and the bottom. We also can cancel our 2's. And so we're really just left with a sine 3x over a cosine 3x. And we know that sine over cosine is equal to tangent. And so that completes that second example with that identity.